Good afternoon. Our main discussion for today is about permutations. To start with, let's have the learning objectives. Learning objective number 1. Define and illustrate permutations. Number 2. Apply permutations in various situational conditions. And lastly, state and illustrate the circular permutation. Now let's have the definition. Permutation is an arrangement of a group of things in a definite order. That is, there is a first element, a second, a third, and etc. In other words, the order or arrange of the elements is important. Let's have an example number 1. The letter A, B, C have the following possible arrangements and permutation. So we have first A, B, C, second A, C, B, B, A, C, B, C, A, C, A, B, and C, B, A. So we have 6 ways of arrangement. In general, n distinct objects can be arranged in n, close and open parenthesis, n minus 1, close and open parenthesis, n minus 2, and then n minus 3, n minus 4, and so on and so forth, until it reaches 3, 2, 1 ways.
Rule number 1.
A permutation of n distinct objects taken n at a time. The number of permutations of n distinct objects take n at a time is n. Npn is equal to p, close and open parenthesis, nn, or the n factorial. The n, and then we have the apostrophe, that is n factorial. We're going to write it on another formula. We have n, close and open parenthesis, n minus 1, n minus 2, and so on and so forth until 3, 2, 1. Sample number 1. In how many ways may a radiologist assign 5 patients to undergo a screen test for pulmonary tuberculosis X-ray? So we have 5 patients, so that's 5. No? So we have 5p 5. So that is equal to 5 factorial, or 5, and then we have the apostrophe. So then we have that in expanded form. We have 5 times 4 times 3 times 2 times 1. So if we're going to multiply these numbers, we have 120 ways. Example number 2. 6 drugs are being tested for their effectiveness in controlling acne. A researcher was asked to rank the drugs from 1 to 6, with the most effective drug receiving a rank of 1. In how many ways of rank 6 drugs, beginning from the most effective one? So we have 6p6, or the 6 factorial. Then that is 6 times 5 times 4 times 3 times 2 times 1. So if we're going to multiply these, we have 720 ways. Example number 3. In how many ways can 4 bottles containing different drugs be arranged on a medicine cabinet, given n is equal to 4? So we have 4p4. Then, that is 4 factorial. So we have 4 times 3 times 2 times 1. So we got 24 ways. So that is for the different drugs. Okay, many ways on a bottle contained on it. Example number 4. In how many ways can 3 nursing students be seated in a row? So the n is equal to 3, then 3p3. So we have 3 factorial. So that is 3 times 2 times 1. So we have 6 seating arrangement for the nursing students. Sample number 5. In how many different ways may 4 newly admitted patients be assigned to 4 available beds in the charity ward of a hospital? So n is equal to 4. Then we have 4 factorial. Then we have 4 times 3 times 2 times 1. And that is 24 ways. So, by the way, this is under rule number 1, okay? So, example number 6, in how many different ways may 7 victims of the cholera epidemic be assigned to a ward with 7 beds if 2 of the victims who are sisters insist on being together? So, we have 6 and 2. So, 6p6 multiplied by 2p. 2p2. So, we have 6 factorial and 2 factorial. Okay? So, then we have 6 times 5 times 4 times 3 times 2 times 1, that's 720. Then we multiply it into 2. Then we will be having 1,440 ways. So, those are for rule number 1. Okay? So, rule number 2. Arrangement of n objects taken are at a time. So, the number of permutation of n distinct objects taken are at a time. So, n p r. So, that's equal to n factorial over close and open parenthesis n minus r factorial. So, there's a factorial there, okay? So, in illustration, we'll be having 5p2. So, we have 5 factorial, close and open parenthesis 5 minus 2. So, then we have 5 times 4 times 3 all over, the 3 factorial all over 3 factorial. So, cancel the 3 factorial, and then we got 5 times 4, and that's 20. Now, let's have an example number 1 for the arrangement of n objects taken are at a time. Of 6 drugs being tested for efficacy against AIDS, 2 drugs are given in combination, one after the other, to test whether they will produce a better effect. The sequence of the combination is utmost important in the experiment. How many possible sequences are there? So we have 6 drugs and then 2 drugs. So that's why we have 6p2. So we have 6 factorial or all over close and open parenthesis 6 minus 2. So that would be 4 factorial. So then we have 6 times 5 times 4 factorial or all over 4 factorial. So our answer is 30 possible sequence. So that is for example number 1. We have 30 possible sequence. Sample number 2. A toxicologist would like to test the effectiveness of the 3 new insecticides on rice field. But he has 7 different locations of barangay. How many different tests could he perform? So there's 3 new insecticide. Then you have 7 barangay. So we have 7p3. So then we have 7 factorial all over close and open parenthesis 7 minus 3 factorial. So then, upon we expand it, we have 7 times 6 times 5 times 4 factorial all over 4 factorial. So we cancel the 4 factorial. So we multiply 7 times 6 times 5, and that is 210. For the third example, we have from a group of 30 patients receiving a standard chemotherapy treatment for lymphoma, 5 can be chosen for an additional experimental treatment that may ameliorate most side effects. How many listing of 5 can be chosen from the initial group of 30? So we have 5. So 5 chosen experimental treatment and then 30 initial group. So we have 30 P5. So then we have 30 factorial all over 30 minus 5 factorial. So then we have, so this is 25. So the 25 is cancelled out. The 25 factorial is cancelled out. So we got 30 times 25 times 28 times 27 times 26. Then we got the final answer of 17,100,720. Okay? So that's all for today for the permutation. This is a linear permutation. We'll be having another continuation of the discussion on permutation. Okay?